So in this video, we're gonna continue with the questions and hopefully complete this topic. So previously we finished up until question 8, so question 9. So we have a line that is 2x plus 5y is equal to 1. And this line meets the curve x squared plus 5xy minus 4y squared plus 10 equals to 0 at the points A and B. So basically, you don't really need to know what these curves look like. So let's just say this is the curve and we have a straight line, something like this. Or it could be with a negative gradient. I think it's with a negative gradient. So we have a line and we have a curve. So they meet at 2 points and we are calling these points A and B. Now, this diagram may not be accurate. I'm just drawing something just to represent how the scenario might look like. And this line intersects the curve at 2 points, A and B. So we are asked to find the coordinates of the points A and B. Well, how do you find the intersection? You just isolate a variable and you substitute into this equation, right? So we can say, hey, 2x, I believe it's easier to isolate y because you have 5xy. So when you have 1 over 5, the cancellation is going to be easier. So 5y is 1 minus 2x. Y is equal to 1 over 5, 1 minus 2x. And let me just have my calculator by my side because we will be needing it, I believe, for calculations. All right. So now that we have isolated y, we can substitute into the curve equation, right? So the curve equation says x squared plus 5x, and then I just substitute y. What is y? Y is 1 over 5, 1 minus 2x. Minus 4, y is 1 over 5, 1 minus 2x squared plus 10 equals to 0. And now we can just simplify. X squared, 5 times 1 over 5, that's just 1. And then I can distribute x inside. So that gives me x minus 2x squared, right? So 5 cancels out with 1 over 5, and then I can distribute x inside the bracket. Minus 4, let me square the term first. So 1 over 5 squared is 1 over 25. And then I have 1 minus 2x whole squared. So that is 1 minus 4x plus 4x squared. Plus 10 equals to 0, right? So if you square this, you're going to get this expression. All right. So x squared plus x minus 2x squared minus, we have 4 over 25, 1 minus 4x plus 4x squared plus 100, plus 10 equals to 0. Now, I don't like working with fractions. And so I'll multiply with 25 because I want to remove the 25 in the denominator. I'll multiply each term. And a term is something that is separated by an addition or a subtraction sign, right? So I'll just multiply each term with 25. So the first term is this. Everything inside the bracket will be my second term. So 25x squared plus 25 times x minus 2x squared minus 4 because the 25 in the denominator is going to cancel out, right? 25 plus 10 is 250. 25 times 0 is just 0. So you have to do it on the right-hand side as well. And now we can simplify, right? So we have 25x squared plus 25x minus 50x squared minus 4 minus 16x plus 16x squared. So I just multiplied 4 inside. Plus 250 equals to 0. And we can collect like terms now. So I have 25x squared minus 50x squared. Remember to take the negative sign. It's minus 16x squared. So 25. So your number is 25 minus 50 minus 16. So that gives you negative 41x squared. So you have simplified your x squared terms. Now let's work on the x terms. I have 25x minus of minus, that is plus. So 25 plus 16. So that is plus 41x. And finally, we have minus 4 plus 250. So that is plus 246 is equal to 0. And let me just check if 246 is divisible by 41. It is. So I can divide by 41. So I get negative x squared plus x plus 6 equals to 0. So I just, because this is divisible by 41, I just divided everything by 41. And I believe it's easier to work with the positive x squared term. So if I just multiply by -1, I get this one. So I just multiplied this equation with -1 on both sides. All right, so this is 246 is divisible by 41, so you just want to divide each term by 41, and you would get this quadratic equation. And I think you can solve this quadratic equation by factoring. And this should be your solution, x minus 3, x plus 2. So therefore, your solutions are x is equal to 3 and x is equal to -2. And now you can solve for y. So y, when x is equal to 3, y is equal to 1 over 5, 1 minus 6, right? 1 minus 3 times 2 is 6. So that is y is equal to -1. So our first point is 3 comma -1. And when x is equal to -2, our y is 1 over 5, 1 plus 4. So that is equal to 1. So our second point is -2 comma 1. All right. So our points look something like this. Point B is 3 comma -1, right? And our point A is -2 comma +1. So like you can imagine, you can sort of use a rough grid paper to plot this point out. So we have found the coordinates, right? That is what the part A asks us to do. So we have found the coordinates. That wasn't a very big issue. But now we want to find the midpoint. So how do we find the midpoint? Well, you can use the midpoint formula. So I know you haven't really done some analytical geometry, but the idea is this. You want to take the average to find the midpoint. So your midpoint is going to occur at the middle value, at the average of your x coordinates and at the average of your y coordinate. So your midpoint is going to be, and let me just give you the formula here, it's x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. So what is your first x coordinate? That is 3. And your second is -2. So that is going to be 3 plus -2, right? And your y is -1 and +1. So 1 plus -1 divided by 2. And that gives you 1 over 2 comma 0. So that should be your midpoint. 1 over 2 comma 0. And that is it. That is how you do question 9. All right. So okay, 9 we have done. So this is just a repeating question. I nearly did it again. So question 10 is very, very similar. They're just asking you, I believe question 10 is almost identical to question 8. So I'll leave 10 for you because this is similar to question 8. So feel free to try it on your own. This is interesting. So we have the curve, right? So question 10 is very similar to question 8. It asks you for the length, and we have done a very similar question here. So this equation, again, we haven't done this yet, but this equation represents a circle. And the circle, let me make this longer. Something like this. So if this is our x and y axes, so we have something like this, a circle. All right, and 25, we can write 25 as 5 squared, and that is our radius. So our radius is 5. And we have a straight line, y is equal to x plus 1, and that is easy to draw. So the graph of y is equal to x plus 1 looks something like this. So this is the situation that let me draw it in a different color actually. Sorry about that. Something like this. Right? Something like this. All right. So now it's going to intersect our circle at 2 points, right? So we are given that the intersection is at A and B. So we can just use the similar techniques. So we know 7y minus x is equal to 25. And it's easier to isolate x, right? So we can say that 7y minus 25 is equal to x. If I isolate y, then I'm going to get y is equal to 1 over 7 times something. That's harder to substitute. So I'll use this equation. And I can substitute it into x squared plus y squared is equal to 25. I know what x is. X is just 7y minus 25 squared plus y squared is equal to 25. 7y squared, that gives me 49y squared minus 25 squared. So minus 25 squared is 625, right? And now what do? I multiply these together. So 7 times minus 25, that is minus 175, and then I need to multiply it by 2. So minus 350y. So you multiply these two together, you get negative 175, and then you multiply by 2. Or you can manually expand it out, whatever you find easier. Plus y squared is equal to 25. All right. So this equation simplifies to 50y squared minus 350y, 625 minus 25. So if you bring 25 to this side, you get plus 600 equals to 0, right? You have to subtract 25 on both sides. And everything here is divisible by 50. So let's divide by 50. I believe this should be your equation, right? So 350 divided by 50 is 7, 600 divided by 50 is 12, and you get this equation when you divide everything by 50. And now, I believe this is something that we can factor. So that should be y minus 4y minus 3 equals to 0. So if you expand this out, you will actually see that you get this equation. And now you get that y minus 4 equals to 0. So y is equal to 4. Y minus 3 equals to 0. Y is equal to 3. All right. So now that we have this established, we can label our graph, right? So our points of intersection. So this graph is not that accurate, actually. So we have our points of intersection are all positive, right? So let me just draw it again, but this is just to represent the situation. But we have our points of intersection. If I draw it without the axes, it's at y4 and y3. So we need to find our x-coordinates. And we can do so by just substituting it into our x equation, which is this one. So 7y minus 25 is equal to x. X, if y is equal to 4, 7 4s at 28 minus 25 is equal to 3. So 4, if y is 4, x is 3. And if y is 3, 21 minus 25 is equal to x, right? 7 times 3 is 21 minus 25. X is equal to negative 4. So I have negative 4 comma 3, 3 comma 4. So these are my 2 points. It says, now I know that this is A and B. So we need a line that cuts perpendicular. Line that is perpendicular to this line. All right. So there are a number of lines, actually. So now a perpendicular bisector, so it's very specific. It says perpendicular bisector. So it must satisfy, so if you're asked to find the perpendicular bisector, it must satisfy 2 conditions. The first condition is that this angle must be 90 degrees. The angle where these AB and our perpendicular bisector meets, that must be 90 degrees. And our second condition is that it must pass through the midpoint of AB. So now we need to find 2 things. First of all, we need to find the slope of AB. The slope, m, is y2 minus y1, y2 minus y1 divided by x2 minus x1. So 4 minus 3 is 1, 3 plus 4 is 7. So that is our slope, right? And let me just give you a formula. If 2 lines are perpendicular perpendicular, so this is the symbol for perpendicular, the product of their slopes is equal to -1. So m1 times m2 is going to be -1. So if we know m1 is 7, we just found the gradient of this AB line, this line. So we can use it in our formula. So 1 over 7 times m2 is equal to -1. So m2 has to be -7. And now, so we know the gradient of this line, and now we also know that it must pass through the midpoint. So what is the midpoint? Let's see. The midpoint is going to be the average, right? So your midpoint, so if you use this information here to calculate the midpoint, you take the average of your x's. So you take 3 plus -4 divided by 2, and you take the average of your y's. That is 4 plus 3 divided by 2. So you get 3 minus 4, that is -1 by 2, 7 by 2. That is your midpoint, right? So this is your midpoint. All right, and now that we have the midpoint, and we have the gradient, so we have the midpoint and we have the gradient, we can use a formula. So there are many ways to write a linear equation, right? So one of the ways is ay plus bx is equal to c. That is one way. You have another form called y2 minus y1 is equal to mx2 minus x1. And we call this the slope. I believe it's not the slope-intercept form. I'm not sure, but this comes from the definition of m. M is y2 minus y1 over x2 minus x1, right? So you just multiply by x2 minus x1 on both sides. So if we use this, we know m, right? So y2 minus y1 of our perpendicular line is just -7. So I just substitute -7 here. x2 minus x1. Now, I don't need y2. I don't need x2. So I'll just write it as x and y, and I'll keep y1 and x1. So this is the formula, actually. So you don't want to remember the 2's. You can just erase them, but you want to remember this formula. And now, y1 is going to be the one point I know, which is the midpoint. It passes through the midpoint. So that point is 7 over 2. So y minus 7 over 2 is equal to -7, x minus -1. I'm so sorry, if the video cut off very abruptly. So basically, y minus 7 over 2, and then -7 times x minus of -1 over 2, right? So now, we can simplify. Y minus 7 over 2, -7, x plus 1 over 2. I don't like working with fractions, so let me multiply by 2 on both sides. I multiply by 2 here, I multiply this by 2. So 2y minus 7, right? 2 times y is 2y, 2 times -7 over 2 is just -7, times -7, if I multiply 2 inside, I get 2x plus 1. And finally, I can simplify. 14x minus 7, and I can write this as 2y plus 14x, I bring this here, is equal to 0. That should be your equation. So let me check the answer, and it is. So you can divide by 2 actually. Y plus 7x is equal to 0. So 7x plus y equal to 0. However you choose to write it, this is your equation. So you can stop here, you can go a bit further, but that is your equation. Y plus 7x is equal to 0. And these are representatives of the same thing, right? So that these two are the same equation. This and this, it's the same equation. So that is your answer. This is your solution. All right, I know it took a lot of work to get to the solution, but I hope it was intuitive. All right. So yeah, the solution is very colorful as well. All right. So 10, I said it's very similar to 8, so I believe you can do it. So we are going to continue. So I believe question 13 is very, very similar to question 11. So we're not gonna, because we've already done 11, then we're gonna skip over 13. So let's finish question 12. We are given a straight line, and this intersects with the curve x squared minus y is equal to 5, and we can directly substitute this here. So x squared minus x plus 1 is equal to 5. So x squared minus x minus 1 is equal to 5. X squared minus x minus 6 is equal to 0. And if I factorize this, you see that you have x. Your factorization is going to give you x minus 3x plus 2. And you can try this on your own, but you get x is 3, x is equal to negative 2 as your solutions. And when you substitute your x values here, you get when x is equal to 3, y is equal to 4. When x is equal to negative 2, y is equal to negative 1. So if you try to visualize the situation, you have a point A, you have a point B, and it's given that A lies below the x-axis. So your A is actually this point, negative 2 comma negative 1, and you can try to imagine why this diagram sort of represents the situation that we have. But we have B is 3 comma positive 4. So negative 1, x-axis is y is equal to 0 is your x-axis, right? So anything below the x-axis should have a negative y coordinate, so negative 1. So we have this situation, and we have a point P. So this says that we have a straight line and a curve. So we have a straight line and a curve, and we have points A and B where they intersect, and a point P lies on AB. So this point P lies on AB such that AB, the ratio of AB to PB is 4:1. And that basically means that, hey, if AB is 5 parts, so if AB, the idea is that AB is 5 parts, then AP is 4 parts, and PB is 1 part. So you have 4 parts of AP and then 1 part of PB giving you the total AB. All right. So that is the idea behind the ratio given here. So how you can imagine this is that you can think of it as vectors. Right? So you are starting from the vector negative 2. So let me write as xy, right? So you are starting from xy is your starting point. So that is a vector. So you're starting from negative 2, negative 1. So that is where you are starting from. And you are going 4/5 of AB, right? So if AB is whole 5 units, then AP is 4 out of those 5 units, right? If AB is the entire 5 units, then AP has to be 4 out of the 5 units, because we know that AP is 4, PB is 1 unit, right? So the ratio of AP to the total length of AB, that is 4/5. And now you can find this vector. You can find this vector AB. And how do you find the vector AB? Well, AB, that is just this vector. So 4x is 3 comma 4, 3, 4 minus negative 2, 1. Negative 2, negative 1. And that gives you 3 minus minus 2 is 5. 4 minus minus 1 is 5. So that is just 5 comma 5. So 4/5 times 5, 5. And basically this is the idea. So if you have 2 points and you want to find this vector, then let's call this x2, y2, x1, y1. Then the vectors, if this is the vector AB, then the vector AB is given by y2 minus y1, x2 minus x1. So we know the vector. And basically, that just means that, hey, in my x direction, I'm going 5 units. And in my y direction, I'm going 5 units. That is what I am representing. I travel 5 units, positive 5 units along my x-axis. I travel positive 5 units along my y-axis to get to I start at A, I travel 5 units on the x-axis, I travel 5 units up the y-axis, I get to point B. That is what I'm saying with this vector. And basically, the question says to get to AP. So this is my P, right? It's not the entire 5 units that I'm going. I'm only need to go 4/5 of those 5 units. So it's only going to be 4/5 of the final vector AB, right? So now I can use that information And if I multiply inside, I get plus 4 over 4, right? If I simplify this. And that gives me 2 comma positive 3. And basically, your final coordinates of your P is going to be 2 comma 3. So your X coordinate always goes up, Y coordinate always is at the lower side. And your solution is 2 comma 3. But the idea is you visualize this AB as a vector. You think of AB as a vector, and you think of AP as a vector, and you know that AP is 4/5 using the ratio of AB. That is the important information. So your AP vector is 4/5 of your AB vector, and you know what your AB vector is, right? You start from A plus 4/5 of your AB vector. So your starting point is A. So you start from your A vector, whatever it is, you travel 4/5 along your AB vector, you get to your AP vector. And that is the equation that we used. This is the equation that we used to solve the question. And we got 2 comma 3. And that should be your final answer. 2 comma 3. And yeah, that is it. Basically, you start here, you start at this point, you travel 4/5 along the vector AB, you get to AP. And you solve this here. So you put your X coordinate as your first component, your Y coordinate as your second component. And how do you get AB? Well, you take the difference of the two coordinates. So you have to have a bit of idea about vectors here to solve this question. Otherwise, it's going to be a bit difficult. The calculations are going to get hard. But I hope the idea of using vectors is intuitive. And in the future, probably we will cover vectors as well. But without using vectors, this is kind of a difficult question to solve. So you get 2 comma 3 at the end. All right. And finally, we have question 14. So 13 is very, very similar to the questions we have previously done. So let's go to 14. So we are asked to split 10 into 2 parts so that the difference between the squares of the parts is 60. So let's just say the parts are A and B. So A plus B has to be 10. So we've split 10 into A and B. They have to add together to give me 10. And difference between the squares of the parts. So let's assume B greater than A, right? So B squared minus A squared is 60. That is what is given, right? Difference between the squares of the parts. So B squared minus... So because I want a positive difference, right? If B is bigger, then the square is bigger. So B squared minus A squared is 60. And I know that A is just 10 minus B. So I can substitute this here. So B squared minus 10 minus B squared is equal to 60. B squared minus 10 squared is 100 minus 20B. If I simplify the bracket, plus B squared is equal to 60. So B squared minus B squared, that cancels out, right? So I get 20B minus 100 is equal to 60, if you simplify. So that gives me 20B is equal to 160. The zeros cancel out, B is equal to 8. And A is going to be 2. And you can check, B squared is 64. 2 squared is 4. 64 minus 4 gives me 60. So the difference between the squares is indeed... So the splitting numbers are going to be 8 and 2. So that is going to be the solution to A. So part B says we have n. So let's split A plus B is equal to n. And again, B greater than A. We are given B squared minus A squared is equal to D. So instead of using concrete numbers, we are just given variables. But the idea to solve this is the same. B squared minus A is going to be n minus B squared is equal to D. And you can simplify. B squared minus n squared minus 2nb plus b squared is equal to D. And if you simplify this, you get 2nb minus n squared is equal to D, I believe. And yeah, so you can solve for B. So 2nb, small b, is equal to D plus n squared. And B is equal to D plus n squared divided by 2n. So another way to express this is just D divided by 2n plus n squared divided by 2n, right? You can split it. And n squared divided by 2n is just n divided by 2. So So you have b is this one, and then a is just going to be n minus b, right? So it's equal to n minus d over 2n plus n over 2. And I believe you get n minus n over 2 is just n over 2 minus d over 2n. So those are your two numbers. So this is the same question essentially, just with different variables. And we are done with this topic.